Let me share my screen. Okay. Hi everyone. I am really glad that you are here and thank you for coming. I'm Hovhannes. I am site reliability engineer from Discord, and today I am going to show you what is API Gateway and how we can leverage it on hybrid environment. By saying hybrid, I mean an environment where you can have servers and also serverless workloads. So today we are going to speak about what is actually API Gateway and what are the needs and how API Gateway can satisfy them. We are going to speak about its configuration and features, some best practices, and at the end we are going to show you a demo how we can configure API Gateway and of course Q&A. So let me introduce API Gateway. It's a managed service by Amazon, which gives us ability to create, publish, maintain, monitor, and secure APIs at any scale. So what does that mean? It's kind of a front door for your backend applications like backend services, AWS Lambda, Amazon Kinesis, Amazon DynamoDB, and also you can have private applications in VPC and even on premises and connect API Gateway to that applications. So let's speak about needs. So what we need and how API Gateway can satisfy. We want to have versioning of our API. We want to manage it, and API Gateway does that. It documents history of your every change in API. We want to monitor access on the API to understand how many invocations there are. We want to authorize each request to understand if that request must pass to backend. We want to also manage traffic spikes because sometimes there can be cases when there is a lot of traffic and we need a service that can automatically scale for us. And also one more advantage that we don't want to manage any servers here. So some basic things that we can do in API Gateway. We can build our API with the resources, methods, and settings. We can, after that, deploy our API to stages. So we can clone from existing API to create new version or even create new API Gateway. And one more cool feature that it has is rollbacks. So if something goes wrong, we can do a rollback of API. So what does that mean, configuring API? First of all, of course, we need to create API in Amazon. There are a lot of ways to create. I personally like using Terraform, but you can also create using AWS Management Console or CLI or CloudFormation or SAM even. So after creating it, we need to define resources in API. In this example, you can see resources are these /market, video, text, which are like HTTP paths of our API gateway. And each resource have its methods, HTTP methods like get, post, options, and other existing HTTP methods that you can use. So we configured, everything is okay, we have tested. Now we want to deploy it. Deployment of API is done in something that is called stages. So you can have multiple stages, and each stage can represent like maybe environments. For example, develop, staging, production, or maybe application names. It doesn't matter. You need to select it. In our demo, we are going to use one stage only because it's what we want. So moving on, some features that API Gateway has. You can see that I have written REST API. In reality, there are three types of API that you can configure in AWS. It's a WebSocket API, REST API, and HTTP API. WebSocket API is for WebSocket-based applications, and HTTP API is kind of the same of like REST API, but with less features. So that's why I'm not going to tell about that. Instead, I'm going to speak about REST API features. So you can see we have caching. We can enable caching on REST API, so it can give a response from its cache. Throttling. Throttling is kind of a limitation on API Gateway. So whenever there are a lot of requests on API Gateway, API Gateway is going to drop some of them. Let me give you an example. Like if you have configured throttling with 10,000 requests per second, and in second you will receive 10,001, that one request is going to get error with 429, too many requests. It's worth to say that there is a limitation on each AWS account on all API gateways, and it's default 10,000 requests per second and 5,000 burst. So it's configurable. You can apply submit form to AWS so they can increase the limit, but be careful with that. And authorization, we can configure Ras. That's okay. Authorization is something that we can use to understand if the request must pass to backend services. In case of REST API, it's using Cognito and Lambda authorizer to do that. We are going to show in demo how we can configure this with Cognito. Resource policies. Resource policies gives us ability to limit access to API with IP level. Like for example, we can limit access to API gateway to some countries, defining policy. We can use custom domain names if we don't want to use default domain of AWS for our application. We can leverage API keys to method usage of API gateway. We can generate SDK. This is one of the cool features that REST API has. So it will generate libraries and code for your existing applications, so you can use it. We can leverage logging. There is destination of CloudWatch, Kinesis Firehose, tracing also using AWS X-Ray, and we can use canary deployments to on production workloads maybe to test new features. Like if you want to send 10% of traffic to new version and 90% of traffic to older version, we can do that with canary. So, and some best practices that I found worth to mention. We can utilize caching, as I said before, to improve performance. We can use HTTP API in cases when we don't need advanced features like AWS WAF or API keys or resource policies. This is a more cheaper version of REST API, and you can save cost up to 70%. Don't use API keys for authorization. It is not for that. Instead, use Cognito Lambda authorizer. This is one common issue that I found in some places they are using. It's not best practice. It's not secure because you are using like same text to authorize requests. Instead, use Cognito Lambda because for that you're going to use token-based mechanism, and each token has expiration date. Use resource policies if you want to block some sources. It is easy and cheaper than connecting WAF. If you want to just block some IP addresses, it's better to use resource policies. Choose endpoint type according to your needs. There are 3 types of endpoints for API Gateway. It's edge optimized, private, and regional. Be careful when selecting because, for example, in HA optimized, it's understood using CloudFront distribution to give less latency for your customers or users. And if your application, for example, is only working in USA or one particular region, it will be not cost effective to use edge optimized. Instead, use regional. In this case, you are going to deploy your API gateway to one region only, and it will save cost. And also, there are situations when regional type is more accurate. And of course, if your applications are internal and you don't want to expose them to public, use private endpoint type. Do not hardcode, use stage variables. This is a feature of stages. You can use variables to define your endpoint names, and it's worth to use. I will show you in demo how we can use that. Try to have separate AWS accounts for each environment and API gateway on each one. It's not only for API gateway, it's connected to everything because when you have separate account, it's more easier and granular access control for every account. And also, if sometimes if you want, for example, your production workload to have more throttling limits, you are going to use this type, and you will submit request, and they will increase only for your production resources. And after all, remember limits for throttling, payload size, timeout, everything. Always remember limits for every serverless application that you are going to use. Okay, so now let's go to demo. We are going to show you in demo, which we speak about in slides in following demo architecture. You can see here we have AWS Amplify, on which we have deployed some UI application. We have API Gateway, we have Cognito for authentication and authorization flow, and we have 3 endpoints. And of course, we are using X-Ray and CloudWatch for logging and tracing. Let me. Oops. Okay, let me go to a UI page. As you can see, we have login page here where we can sign in or create new account. I'm not going to do new account. I'm going to sign in with my existing credentials, and my user is defined incognito user pool. So after logging in, I am going to get access token from Cognito. Here you can see in this page, I have received access token. Before moving on, I want to show how it's configured in API Gateway console. So here it's our API Gateway. As you can see here, we have resources defined, and the place where we define our authorizer, it's here. You can see that we can add new authorizers, we can create new ones, so we can select type Lambda or Cognito. I'm not going to do that. I'm now going to choose my existing one. As you can see, it's type Cognito. I have defined name of my user pool and also token source. This is the source from HTTP header from where API Gateway is going to get this information and pass to Cognito to verify if that request is allowed to do something. After creating authorizer, there is need also to define this authorizer on methods, like for get methods or post methods. We need to define them on each one if we want to have this authorization flow. It's easy. We need to go to method. We need to go to method request and choose authorization, choose which type we want, Here you can see that I have this authorizer. I'm going to select this, and that's it. Let's go back to UI and understand what we have here there. You can see we have here 4 sections: video, market, text, and set image, and each one of them is representing one type of endpoint. So in case of video, whenever I'm clicking on this button, it is going to send HTTP request to API. You can see from here its URL, and method is get. And one more thing that I want to show here, it's this authorization header where I'm sending my GBT token. And of course, I'm getting response with this message, which is rendered on UI. Let's go back to console and see how it's configured. Here you can see these options methods on each resource. This is enabled for cores, so our UI can get this information. Let's go to this get method, and you can see here we have method request where I've configured authorization, but the connection to backend is configured under this integration request. So here we have types where we can select which type of backend we have. In this case, it's a Lambda function. And here I've selected in which region my Lambda is and function name. So that's it. It's nothing else, and it's working. Let's go now to market section. Here from UI perspective, you can see it's like same, but whenever I type this button, I'm going to send now request to market endpoint and get response with this message. Let's see how it's configured in UI, in the API Gateway console, sorry. But before that, let's one more time view our architecture. You can see that in case of market, we have private EC2 instances, and in order to connect to that EC2 instances, we have private link. We configured private link to connect to network load balancer, and that load balancer is in order is connected to autoscaling group of EC2 instances. Here from my API Gateway UI, we can see it here in this integration request. You can see its type is VPC link. We have used proxy integration. We have method get, and you remember I was speaking about stage variables. Here I am using stage variable to define my VPC link. Let me show you where it's configured. So I have this dev stage, only this one, and here under stage variables I have my VPC link ID and its value. This is best practice, and you can use it. For example, if you have prod and you have another VPC link for that, you can define that VPC link ID in its stage, and you can use this API Gateway for both of them. So let's go back to our UI, and third section, text. This one is interesting because for this, let's go back to one more time to demo architecture. You can see in case of text, we are directly speaking with DynamoDB, and we are getting some information from there, and we are writing something there. As you can see, we don't have any intermediate service like EC2 or Lambda. We are directly doing this, and I am going to show you how it's done. But before that, let's see how it's working actually. So if I want to add something in DynamoDB, I'm going to write here some text and click this button. I'm going to write another text and click one more time, and it's going to write in DynamoDB. It's going to do post call to our API Gateway with this payload ID and text. So let's go and see how it's configured in API Gateway console. Let's go to post method definition. And here you can see in integration request, we have selected AWS service, we have selected region, vService, in this case is Dynamo. Here you can see there are a lot of services which can be connected, and HTTP method is post. We are going to do path item type of action on DynamoDB. So let's go back and remember we are sending this, but doing this action. And how DynamoDB will understand what we want to do. We have mapping template defined here, where API Gateway is going to modify our request. It's going to rewrite body to be in this form. You can see here there is table name with item, under which it's going to put our data. Almost same is done for get request. So in order to get something from DynamoDB, I'm going to use ID, and I'm going to click this button. You can see from my network pane, I'm doing HTTP call with query parameter here, and I'm receiving response in this form. Let's go again to API Gateway console, and here in integration request, it's again almost everything is same. Even HTTP method is post, but we are doing get actually, and we are doing action query. We have mapping template again here, but this time it's different, because for query, DynamoDB will wait from us this payload. And if we do this type of query, we are going to receive a lot of things from backend, from DynamoDB. And for that, so we don't want user to see everything there. For that, there is something which is called integration response, which gives us ability to modify up response from DynamoDB in this case. Here we have again mapping template, which is defined here, and it's going to return to user only this ID and text in this form, and that's why in here in response we see this. Okay, so we have also other section, image section, and if you click on it, you can see that it's not working. We don't have anything here. Let's create this resource. Image endpoint is going to be again Lambda, and let's create. To do that, we need to create image resource name here. Okay, we are going to create method. In this case, we need get method. We are going to select Lambda function. We are going to check this box because I want to use proxy. And this Lambda function, we are going to select the name. And when we click save, it's giving us some notification that it's going to give permission to API Gateway to invoke this Lambda function. Okay, everything is good. I'm going to add also authorizer here to be authorized before doing calls. And one more thing, I need to enable CORS on this resource. Let's enable it. Okay, so before deploying, I want to test. I can test here from this UI. Just type on test and like this, because we don't need any query string here, any other. You can see status is 200, response body is here. Everything is okay, so now we can deploy it. To do that, we need to deploy API, select stage in which we want, and add some maybe description. So let's wait. And let's try now. Okay, so here you can see it's now started to work. And let's imagine situation when this feature has some bug and we want to roll back our changes. We can do it from here, from stages. As you remember, we have rollback functionality. So here in stage, we can go to deployment history and select which deployment we want to roll back. So here we have stable deployments deployer. I'm going to roll back to this one. And let's now try one more time. You can see that it's started to not work. Okay. And one more thing that I want to show you is monitoring of this all, how you can find some information to understand what's not working. We have enabled traces for X-ray, so we can go to this page. It's CloudWatch, and under CloudWatch there is X-ray traces, and here let's find our API gateway. Here it is, UG demo and stage name. I am going to add this to my query. And here you can see all calls to my API gateway. Let's see this one, for example. So you can see that it's this call destination is Lambda. And from here, I can troubleshoot. I can find in which stage, in which step something is broken, or maybe there is a complaint about duration. Here I can troubleshoot in which particular step there is duration is high. If it's not something that we need, we can also go to logs, which we configured. There are two types of logs for API Gateway: execution logs and access logs. Execution logs are going to give logs of API Gateway itself, what it does, and access logs are just access logs, who have accessed it and which status code they received. So to find execution logs, it's starting with this name, API Gateway execution logs, and after that, API Gateway ID. So I'm going here, I'm going to find last event. I'm going to here, and I can see my everything that is done from API Gateway's perspective, every single log. If that's not enough, I can go to access logs, which is configured from here, from this logs for stage. Here I am giving destination IRN. It's CloudWatch log group IRN. I'm going to find this from UI. Okay. And I can see who have accessed my API gateway and what status code they have received. Like 403. That's okay. It was not working. This one. This one is also 403. Let's go below. Okay, this one is 200. So this is working case. So you can have some monitoring on your API gateway to understand what's going on there. And let's go back to our slides. And yep, thank you very much for listening me. I hope it was interesting. And you can use this QR to leave feedback for me. I will appreciate it. And if you have some questions, feel free to ask.
So, okay. So one question regarding the authorization section. You mentioned Cognito and Lambda function. what if I have another OIDC provider? Will I be able to use some sort of workaround or something different? Thank you.
Mhm. Yes, of course, there isn't a direct way to do that, but Lambda authorizer is especially for that. So you can write your custom code in Lambda authorizer to connect to your third-party OIDC. Uh, in case of Cognito, you can do that, or even if you can, it will be really hard. But with Lambda, you can do that.
So there's nothing out of the box, just like the one mentioned in the ALB.
Mm.
Like in the application load balancer, you select the OIDC, you fill in the.
No, no. Unfortunately, there is no direct way to integrate.
First of all, thank you for your speech. It was great. Can you explain to us what are drawbacks of using AWS API Gateway and what are CVs or I don't know cons, reasons to not use it? Because from the first look, it looks like just why not to use it, but I'm sure that there are some drawbacks that will be very hard to go.
Mhm. Yeah, sure. There are some cases when you don't need. And if you remember in one of the slides, I spoke about limits. There are each AWS serverless service have really hard limits on it. Like for example, in API Gateway case, we found that there is default timeout duration 29 seconds, and if you are going to connect your service to API Gateway, and if execution of that service is higher than 29 seconds, you are going to receive every time errors from API Gateway that there is timeout, but your application in backend is going to be okay. So this is the case, one case only that I can say from my personal experience. But in many cases, API Gateway comes handy if especially if you want to deploy something and to understand if it's working or not. But when your usage is really high, uh, it's worth to understand is it worth to use API Gateway. And of course, remember about throttling as well. When you have throttling on your API Gateway, it's going to drop uh, some amount of requests. So keep in mind that also. Yeah, only con for this for me is limitations, and it's not only for API Gateway.
Hello, I have another question. Thanks a lot for your report. It was very interesting, and I'm a bit concerned about the security because DynamoDB is not allowing by default any connection. Yes, it's a public service, and it would be allowed for API gateway to connect to DynamoDB. So, was it done in advance, or it was just done like you did with Lambda, that when you configure something, it is creating appropriate security policy to connect to DynamoDB?
Yes, particularly when you are trying to connect your API gateway to your backend service like AWS Service DynamoDB, you are going to use a IAM role to do that. And of course, you can limit that role access to do only things that you want. Like in our case, it's path item and query. You can define in your policy to limit. And I think from security perspective, that's one layer to do that. Any other questions? Have my answer satisfied you? No. I know. Okay. Mhm.
also API Gateway in AWS, and also you have servers that you have on premises. I wonder if you have such an experience and why would I do that?
Nope, but I know how it's done. You're going to connect your on-premises via VPN to your VPC, and after that you are going to deploy API Gateway to that VPC to a private link, and you are going to select VPC link type of integration as I show it for EC2 instances cases. The drawback of that is if you are going to use REST API, you are going to use AWS network load balancer. So in any case, you need network load balancer to connect to your VPC. And after that, you can connect that network load balancer to your on-premises servers to redirect calls to there.
Okay,
I think that's it. Okay.